Alrighty, happy Wednesday. We made it. I wanted to spend a little bit more time on the lab here. Again, this is much more of the problem-solving thought exercise than it necessarily is getting it into code. Right? The actual code is just going to be two loops. Nothing super crazy and grabbing things out by index. Doing the encrypt side, again, encryption is really the wrong word here, but forgive me. That we were using slicing, and we could give strides. That worked out really nice because, hey, we've got this shortcut. I'm just going to grab every third character, every fourth character, every nth character. That works out really well. But to reverse that process, we can't just grab every nth character, right? That just doesn't work because I now have chunks of characters here. So we spent a little bit of time kind of drawing this out here. Let me zoom in a little bit here. So we had, what do we say, salted popcorn was our example that we used in the lab. So if we wanted to do this for n number of whatever our stride happened to be, so 3 becomes the hard one pretty quick here because we run into different sized chunks here. So I want every third character. So I want the S, and then I want the T, and then I want the space, and then I want the P, and then I want the N. That's every third character. That's for the first chunk. And we did it with the stride. Okay, starting at index 0, I want to stride 3. That gets every third character. And then I go, okay, next index, index 1, give me every third character. And stride takes care of that for us again. So we get A, and then we get E, and then we get O, and then we get R. Right? That's our next chunk here. Right? Let me divide these up. Oh no, I'm missing a letter, aren't I? So A, E, 1, 2, 3. Oh no, sorry, P. There we go, P. 1, 2, 3, C, and then N. There we go. So A, E, P, C, N is every third letter, and I'll break that up again. I'll zoom in a little bit more. And then starting at the second index, every third character, right? I'll get L, I'll get D, I'll get the 1, 2, 3, the O, and then I'll get the other O, right? And then I'm out of characters. So what becomes hard now is in this scrambled up, whatever, chunked up word, I like calling them chunks here, there's different numbers of characters, right? They all have at least 4, and we looked at, well, how do we find out how many they all have, right? That's the length of our word, right? Floor divided by the stride, right? Because that'll be the rounded down, right? Get rid of the decimal if there's any sort of remainders here, so they all have at least 4, right? This was, I think, 14 characters or something. 13 characters, thank you. 7 and 6 and 7. No, 14, I think, right? Salted is 6, the space, and then 7. I think it's 14. Because we get 4, 4, and 4 is 12 plus 2 more.
Oh, yeah, I was thinking probably index.
Okay, yep. So that's how we get the minimum size, right? So each chunk has at least 4 letters. Some of them have more letters. So we said, okay, well, the length modulus, the stride, right, that's going to be the remainder. That's how many chunks will have extra characters. So with that information, then I should be able to go and say, okay, I want to take the first character of the first chunk, the first character of the second chunk, the first character of the third chunk. Right, just kind of doing that back in English. So let me look at the first one and grab it of this chunk. Let me look at the first one of this one and grab it. Let me look at the first one of this one and grab it. And then go back. Look at this next character of the first one, the second character of the second one, the second character of the third one. Then the first character of the first one, the first character, or the third character, and the third character. All right, go to the next one. Now we're at the fourth character. Grab the fourth character, the fourth character, the fourth character. But now I've got extra characters in some number of chunks here. I've got some remaining, well, and the number of remaining characters is whatever the remainder was here. So now I have to go back again, and for that many characters, go try and find them here. So the problem is the distance between these is not always going to be the same here, right? So from the first character to the first character was 5. The first character to the first character was another 5. That one worked out here. But what if our word was salted popcorn? Because we typoed it. There was no N here. It's 5 and then 4. 5 and then 4, right? So the distance is changing. That's why we can't do the stride to put this thing back together, right? So we know it's at least 4, and it might be more if we had a remainder, based on that remainder. So that was the tricky part with this one here. Let me go pull up PyCharm here. We call this one Lab 5. We'll get this one started here. project lab 5. Come on, PyCharm. There we go. Ugh. All right, so we had the encrypt function, given some string and the stride. Right, this one was pretty quick. So we had the scrambled string starts off as nothing here, and then for starting index or something, in range the stride. This gets from 0 to 1 to 2, whatever stride was. We'll do that many. I'll take my scrambled string, and I'm going to add to it here my sum string, starting at the starting index, going all the way to the end of the stride. Right? So start at the first character, index 0, and take every x characters, every n characters, and then go to 1, grab every n characters, go to 2, grab every n characters. So whatever stride you give me, I'm going to work with here. And it should work all the way up through. And then now that we have that, then we're going to do that extra step of adding the index value to its ordinal value, turning back to a character. I'm just going to skip that for now, if that's okay with you. That part was pretty straightforward, I hope. So I'm just going to return the scrambled string. Right? And then for decrypt, right, we have to reverse this. So this is the scrambled string, and we need to know the stride. So again, we're skipping over that step just to make this a little bit quicker here. So we needed to know how big each chunk was. Right? So this is our chunk size, was going to be the length of my scrambled string, floor divided by the stride. They're at least that long, right? And then I'll have my the number of extra characters, or remainder maybe, we'll just call it the remainder, is the length of my scrambled string, modulus the stride, right? So then for the chunk size, right, I need to go through and grab a bunch of characters. This character out of this chunk, 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 right? So I need to know how many chunks I have, right? Or I can just keep on jumping my characters here. This will work with chunk size too. So I'm going to have my original string starts off as nothing, and now I need to go and grab a bunch of characters out of each chunk, right? So for starting index in the range of chunk size, right? So this will be for 0, start at 0, and then 1, start at 1, and then for 2, for 3, for 4, or wherever we're going here with our chunk size. And then again, it's not inclusive of range, right? Or inclusive of the max number. So if the chunk size is 4 here, because I know they're all 4 characters, I'll get index 0, index 1, index 2, and index 3. I won't get index 4. Right? It's not quite there yet. Right? So from that starting index, then now I need to go through and start grabbing characters out, making sure that I'm grabbing and jumping the right number of characters. So some of them are 4, some of them I'll post it on GitHub when I'm done if you want. So I'm going to have this as my chunk number. Starts off at 0. Right? I'm starting in chunk 0 here every time. Then I'm going to go through and take the character, so the original string, I'm going to add to it my scrambled string at, now I don't want to use starting index every time. I want like the current index then is going to equal the starting index. We'll start off at the current index here. And I can say, while my current index is less than the length of my scrambled string. Then I can keep on going. So I'm going to grab characters. So I'm going to take the character at that index, or the current index here. So where I'm starting, right, it was either 0, 1, 2, 3, wherever it happens to be. And then as long as that current index that I'm looking at is less than the length of the scrambled string, I can keep on grabbing characters here. So I'm going to grab a character, and I'm going to take my current index, and I'm going to add to it the chunk size. Right? So at least 4 every time. Now I might need to grab an extra one here. So to know if I need to jump another character, because this particular chunk had 5 or not, I can check if the chunk number is less than the remainder. Then I'll take my current index and I'll add one more to it. Right? If this chunk has an extra character in it because there was a remainder, I need to go one more character. Right? So this way, at chunk 0, I'm going to jump 5 characters instead of 4. Right? Because I jumped at least 4, right? And now I need to jump one more because this one has a 5th character. So I can say, oh, if there was a remainder and the chunk that I'm in is less than that remainder, go for it. Then after that, I'll take my chunk number and I'll also increase that by 1. So I've done one chunk here, looked at the first chunk, chunk 0, and I go to the next one, right? So if there is no remainder, if the remainder was 0 and I'm at chunk number 0, I don't go one more. If it would happen to be 12 characters and all 3 chunks had 4 letters in it, nothing changes, right? I just go by 4, I go by 4, I go by 4, I go by 4. If it was salted popcorn, I go by 5, and then I go by 5, and I go by 4. Like, that's it. If it was salted popcorn, and I forgot the N here, I'll go 5, and then 4 for the next jump here, to make sure I'm not jumping too far here. Then this loop eventually will stop here, right? Eventually we'll go past that because we've added our chunk size. We went beyond the end of the string here. We go back and reset. Okay, now we're back at chunk 0. Now I'm starting at index 1. Grab the second character out of the first chunk. Go 4 or 5. Go 4 or 5. Go 4 or 5. Right, grab characters here. Eventually, when we're done, we can return the original string. Right. So we could our encrypted string was going to be the encrypt function of salted popcorn with a stride of 3. I'm just going to print it here for fun. Print encrypted string, and then we'll have the decrypted string. Decrypted string will be the decrypt function, whatever we get back from that here, right, given the encrypted string, and same stride of 3. And then we can print out the decrypted string. So if it works, we should get salted popcorn. Oh, well, we missed our last 2 letters, right? Well, we got all the way through the chunk size, but I still had remaining characters, right? We didn't deal with the remaining characters yet. So after all of this is done, then, right, I need to say for, I don't know what character in range of remainder, right? There must be more characters if I've got a remainder. If it's 0, nothing happens, right? We don't range to 0. If I've got something here, if I have 1 remaining character, this will run 1 time. If I have 2 remaining characters, it'll run 2 times, right? So I need to grab my, sorry, so the current index is going to start at the chunk size. Chunk size. So if the chunk size was 4, this thing stopped before I got to index 4. Right? I got index 0, 1, 2, and 3. I grabbed the first character, the second character, the third character, the fourth character. I didn't grab the remaining character here. So current index is there. I'm going to take my original string plus equals the encrypted string at the current index. Then I'm going to take my current index plus equals the chunk size. Oops, chunk size, there we go, plus 1. Because if there's a remainder, I know they're always going to have extra characters here. I know that length was 5. If there wasn't a remainder, length wasn't 5. So this will, for as many remaining characters as I have, I'll go grab that hanging 5th character or whatever happened to be here. So now we should get salted popcorn back. And this should work for any different length of strings here. So salted popcorns, sure, that, I mean, doesn't make a lot of sense here. But we get it back out, and with an exclamation mark, right? So now we get 6 characters in the first chunk, and then 5 characters and 5 characters, right? And it's putting it back in the right order. So it should work for any sort of length here. And if you want to get really silly, we could say I want, let me go back to just my sum string. So sum string, I'll just call it the message, why not? Message is salted popcorn here. Do you ever wonder, like, have we thought, does any other sort of food explode if we heat it and it gets tasty? Why do we stop at just popcorn? Like, we heat up popcorn and it pops and explodes and turns into popcorn and is yummy?
My friend one time, like, microwaved an egg, it exploded.
Yeah, eggs were not good to microwave like that?
They exploded.
Apparently you can do popped rice. And that's actually pretty good. It's a lot of work though. But all right, so anyway, so we have salted popcorn. So we'll say for, I don't know what, stride in range, the length of salted popcorn, the length of our message. We're going to, we want the encrypted string. Encrypted string will be the encrypt function of our message for the given stride. And then we're going to print the encrypted string. Encrypted string, and then we'll print the decrypt version of the encrypted string. Right, so we should get salted popcorn, something scrambled. Salted popcorn, something scrambled. Salted popcorn, something scrambled here. Just a bunch of times, oops, for the same stride. Right, to see, does it work at a bunch of different strides here? Oops. We can't start at 0, that's right. So with a stride of 1, if you take every single character, every one character, you don't even scramble, right? Every other character, right? Every third character, every fourth character, every fifth character, sixth character, seventh character, eighth character, every ninth character, every 10th character, 11th character, 12th character, 13th, 14th. So like this is barely scrambled now, right? Because we only had, what, a couple times we could grab every 14th character? Twice, 3 times, right? At 15, we got, here's the first letter, and then the last letter, and then everything else, there was nothing after that to scramble up, right? So eventually our scramble gets to be a little silly here. But just to show it works for every length. At some point, if we weren't handling this remainder properly, it would break. It would only work for ones that evenly chunked up here. Does that make sense? So again, we didn't do anything really fancy with strings. We just took, here's a character out of it. We've done that with strings already for a long time here. The tricky part with this was the thought exercise of how do I reverse the process? And I had a chance to show you in lab that the chatbot could not do it, at least on the first try. I didn't bother yelling at it and telling it it's bad and it should try harder. Sometimes that works with the chatbot. Believe it or not, you can shame the chatbot into solving it correctly. But at least on the first attempt, we still scored a point because humans did better. But this sort of thing, this does not look like this in reverse, right? Like this is 2 lines of code, 3, I guess, if you want to count the starting string. 3 lines of code versus a bunch here to undo something that seems so simple. And that's how some problems are. Like when we just imagine there's a problem to solve in code, it might sound really easy, and then weird parts of it get hard. That's okay, right? So getting something broken down into simple enough steps so a computer can do it is hard work. That's the fun part of programming, right? We're kind of like solving puzzles as we go here. In the real world, not that all the puzzles aren't quite as fun necessarily, but that's what we're trying to do. How do we take something complex and make it simple so we can write code to do that thing? Because it's really hard to write code to do complex things, right? It's much easier to write code to do simple things. Like, okay, here's 1 letter at a time. Okay, here's where we have to start, right? We have to break this down into very simple steps here. We okay with this? I'll go ahead and post that. The striding bit, that was the fun part here, right? We could have done this without striding, right? With going through and just saying, okay, let me take the index and add a number to it, take the index, add a number to it, take the index, add a number to it, right? We could do that on our own with loops here, but Python gives us that shortcut with string slicing that we talked about here. So here's lab 5. And again, this is not complete, right? Because I didn't actually add the ordinal values or turn them into characters and do the further step to obfuscate it. All right, and salted popcorns. Are you more of a salted popcorn or caramel corn or cheddar corn or just traditional corn? What do you guys like?
Salted is the best. Anything else is just bad. Just
salted, so you don't get the tri-tin that has, what about chocolate covered?
No, that's bad. Then you get your fingers dirty.
What other kinds of popcorn do you guys like? Why do we have this class at lunchtime? This is so bad. I'm always hungry.
I like caramel.
Caramel corn? With nuts or without nuts? That's good stuff. Bad for my diabetes, but it's good stuff. All right, so we got that one pushed. So let me go back to our strings here. And we only had one last section here in Zybooks. Here, I'm going to check on reporting and make people feel bad. Does it help when I make you feel bad about keeping up here? It's supposed to be like a nice reminder. Okay, I was joking about making you feel bad, but sometimes that works. So 7%, 6% of the challenges. All right, we're getting up there. We're getting up there here. Still not really any of these more than half, though. I think that makes sense because only about half the class actually shows up in person. I think the other half watches online, right? Is that 3, 6, 9? Yeah, out of 18, 19 people, or about half. So it's probably what I expect, but could be better. Right? And it gets worse as we go. I promise you the Xylabs don't get faster. I keep reminding you because I get people frustrated at me at the end of the semester when they're like, oh, I didn't get my Xylabs done. And then they're mad at me that I gave them so much work. Like, yeah, but we had 15 weeks. It wasn't meant to be done on final exam week. That makes for a bad final exam week, I promise you. You have other important things to do. Yeah?
Are we supposed to be on 7 this week?
Yeah, we got into the strings. Yep, this is our topic for this week. So, okay, I won't belabor that too much, but that's your weekly reminder to please read your textbook. Okay, that just feels bad to ask, but that's okay. I was there too. You at least like skim through it, right? Something. Okay, so splitting and joining. So one of the exercises we looked at here was saying, hey, I want to split my word every time I find a space. And this was a small pain to do here, to try and find a space and then slice it, right, from where I started last time up to the space and take these things out here. And as that feels like a lot of work and there should be a shortcut, good news, there is a shortcut. It's string splitting, right? We essentially split the string up on spaces. We want to define a space. You can split a string up on anything you want here, and it's built right into Python. So we'll go up to the top here. It'll be a little out of order, but then it'll run at the top for our program here. Excuse me. So we'll ask for some sentence again. Sentence is an input of enter a sentence. And then what I'm going to do is I'm going to print my sentence dot split. So there's a split function, right, that we're going to call. And what do we want to split on? I want to split on a space. Now, by default, you'll get a space here. I think if we hover over split, it should tell us here, yep, that returns a list of the substrings in the string using sep as the separator string. Sep, the separator used to split the string. When set to none, the default value will split on any white space character, including and spaces. So I'm pretty sure that's the new line character. It doesn't render because it went down a line, tabs and things, and we'll discard empty strings from the result. So if you have like space, 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 we're not going to get anything there because it's empty. Right? It found a space, there's nothing between it and the next space. Found a space, nothing between it and the next space. Nothing here. And then you can also give it a max split if you want, maximum number of splits. Usually you don't want a limit here, but you can if you really want. So this is great for delimited data. Right? If it has delimited, like comma separated values, you can find every comma and separate it out if you're working with the data in Excel or something. Any sort of character you want. But so if we don't give it something we want to split on, so we get to enter a sentence. What do we have? The quick brown fox jumped over the lazy dog. Or was it dog jumped over the fox? I can't never remember here. And we get, look, it's a list with all the values in it. How handy is that? And all the spaces are gone because we split on spaces. Now, you can do it on different things here. So we can split on, I don't know, how about like the letter E? I don't know why you'd want to, but sure. This will find every letter E then, and it removes the thing you're splitting on, right? So it removed all the spaces. It removes the delimiter. So it removes the E, and then we get, there's only a couple E's in this one, not too bad, right? 1, 2, 3, 4, 5 E's? 4 E's? 4, I think, right? Because, yeah, we found one in the middle, one here, one here, one here. Not bad for having every letter of the alphabet and only repeating E's a couple times. But you can split on something, whatever you want to split on, without having to go find it yourself, right? Where we said, hey, give me the index of this, and as long as it's not a -1, I know there must be another one, get the index, go and split, remember where I started. It does all that hard work for us. So splitting is super handy if you've got something you want to split into pieces, right? Now, CSVs are pretty common. It turns out there's an even better shortcut once we get there for our comma-separated values. Like Python just knows how to read those too, without even us having to go split into commas, because that has its own headache as well. We'll get to that when we start talking about files. So splitting is great, and then the opposite of splitting is joining. It takes a list and turns it back into a string here. So if I want to, I don't even know why I would do it as like a separate string here, but we could. So maybe we'll have first name is an input of enter your first name, and then we'll do last name. Oh, last name. Last name. And then what I can do is, if those are in a list, I can join them together. So I'll take, a names list then is first name and last name. This is a little bit convoluted, just to get a list here. And then I can print names.join. I'm sorry. What do we want to join these up with? So how about a space? So space.join names. So here's the string I want to put between everything in the list. And everything in the list then will get a space put together with it. So eventually, oops, oh, okay, that's fine. Eric Charneski. And now we get my name back together with a space here in the middle, which is nice. That's funny, I pasted that in, I thought that was in my clipboard. That worked out okay. So if you have a list of values, we can put them back as a single string, right? This is going to be helpful for you in your assignment here. So when we look at Hangman here, if you want to tell someone when you get a letter guessed what letters they've already guessed, and those letters guessed happens to be a list, right? Like the letters guessed is a list of these things. Okay, I'm going to add one letter at a time. You can print out a list of things with spaces in between by saying print space join, here's the list of things. This works out really nice. So we don't even have to loop through for each item and change the ending value. And you can imagine playing Hangman and like every letter is on its own line. You've guessed, here's 7 different letters you've guessed and you get 7 new lines. That's not pretty. So we could change the ending character, right? Like any of this stuff we could do without joins. This is just a shortcut for us, right? If I wanted to do the same thing, I could say for name and names, here's my final string or something. Starts off with this, I'll take my final string, and I add the name to it. And then what gets weird though is I usually then want to add a space here. But what if I don't want a space at the end? Like if we were like comma separating these things, you don't want a trailing comma here, right? So let's do commas, right? Because commas are fun here. So let's add a comma. Oh, we got to print out the final string. We're done, right? So print final string. Final string. There we go. Start that again. All right. Here's Eric Charneski. So now we get comma separated Eric Charneski with the join, but this version here has a trailing comma, which just looks silly. We don't want that, right? So join takes care of not adding these to the very end. For us, what we could do then, we could say our final string equals the final string sliced here. So if I know I added one too many, just start at the beginning, go to 1 minus the end. Right? Remember, we can use our slice notation and say stop 1 before the end here. That'll trim off that last trailing comma here. Eric and Charneski. And now they look a little bit better. So we can do the thing join does on our own here. It just takes more work, right? So using join is just a little shortcut for us. Using the string slicing is just a shortcut for us, right? We could do all the slicing stuff before, we could do all the striding stuff before, we would just have to do it on our own, right? And then go, okay, now on a +3, on a +4, plus whatever happens to be here. So these are just shortcuts for us, because Python is full of shortcuts. Those people are like, wouldn't it be nice if we could just do this easily? And the fine folks at Python said, yeah, sure, we'll make this built in for you. So here's a function called split. You can split. And you can split on multiple letters here if you want. Right? It doesn't have to be a single character here. Like EEE, if you want, you're probably not going to find many things with an EEE in it, but I'll do a couple in here. it found a couple EEEs, right? Had a couple of them in here. I took them out. So it doesn't have to be a single character, right? Just anything you want to find in here, you can go split on, which is pretty fun. So splitting and joining, right? Split, split. Yeah, so if you wanted to like split a phone number into area code, and there's like the next 3 digits mean something. I can never remember what it's called here. That might be more interesting here. So enter a phone number. Number is an input of enter a phone number. Now, you probably can't turn phone numbers into integers because when people enter them, they do dashes, or sometimes they do parentheses, or sometimes they do funny things here, right? Like, so we're going to get something weird looking, but I need to make sure it actually fits as I go, right? So maybe I want to go and split it here. So maybe I can have the parts here is phone number dot split on, how about a dash? Assuming you probably put a dash in here. I can print the area code will be parts index of 0, and then print, I don't know, the rest of it, local number, bless you. So this is parts of 1 and parts of 2. Parts of, there's a space here then, right? And then parts of 2. Now this is going to break real quick here if I don't give it something with a bunch of dashes, but that's okay. We can fix that later, right? So if we enter sales number, here's the area code, here's the local bit of it here, right? So we can split on the dash here to make sure this actually fits, these sorts of things. Now, again, if I didn't use dashes, if I did like bullets, because I think bullets are fun, 248, 762, 4206, I get, crashes here, list index out of range. So not checking the length of your parts here after you split is probably a bad idea, right? But again, it's okay. People are going to give us some weird input. We can handle that sort of thing later. But splitting on characters is fun. We can go split our strings. You can split a URL, because that's super useful, I'm sure. I don't know. Some of these examples are a little bit stretched here, but that's okay. Splitting, and then joining the opposite here. Oh, look, we can put someone's email address back together if I have their company name. Sure, why not? Yeah, so joining the hard way, joining the easy way. Right? Either case for us is fine here. You can split things and join things here. Right? Put them all together. All right, awesome. That went pretty good. How do you feel about strings? Fun stuff? Yeah, they're okay. It's just going to take practice, right? And that's why we've got a bunch of labs for your practice. So they're good for you. Palindromes are really fun. Palindromes are fun. Words that are spelled the same forward and backwards. So you can check for palindromes pretty quick. Right, we just read the outsides and then in and see if we find a match or not. Excuse me. Mad Lib with loops. Mad Libs are fun too. All right. Do you know what we're doing with Hangman? Does this feel like this is doable at this point? And it's going to take a little bit here. And again, specifically, we need these functions here to practice these specific things here. Right? Not just whatever solution you find online. It's not going to cut it. Right? So points are by function, by function, by function, by function. Here, you do specific things. So to get a letter guessed, given the letter's guessed. So don't let them guess the same one. Right? Make sure it's a single letter. Return that letter that they guessed. Here, we're just breaking it up into small pieces. We've done some of that functional decomposition here. Here's a big problem. How do you write Hangman? And broke it down. Okay, how do I do this part of the Hangman game? How do I do this part of the Hangman game? Because we can solve small problems much easier than we can solve big problems. Right? Just like in real life. All right. I don't actually have too much more right now. I don't mean to keep you super long. We could get started on Xylabs or on the project, whichever one. Projects are worth more overall in your grade. Xybooks are only 10%. Your projects are worth more than that overall. So, and I think I got that all fixed up in the assignment section for you. I didn't add the midterm yet, but all the weights should be here correctly now. So labs are 10%, projects are 30, Xybooks is 10, the midterm will be 10, the final's 40, right? So we'll do that. We've got one more project after this, right, of our 4 projects coming up. So we've got, looking towards the end of October already, believe it or not. This one, we'll do our midterm review and the midterm exam on, and again, I don't like to watch people take tests. It's terribly dull here. So it'll start on 10:30, it'll open. And anytime you want to take it before 11:04, I'm great, right? Not everyone likes to take tests at 12:30 in the afternoon. I get it, that's okay. So whatever time is good for you, go ahead and take it. It'll be okay. You're going to agree not to cheat on it, and I will assume that that's fair, unless I know otherwise, yeah.
Is it multiple choice?
So no, I hate multiple choice questions. That's the worst way to know if someone actually knows something. I don't know why we still do that. I know why we still do it in education, because it's quick, right? How else can you manage 30 people in a class? Like, you can't do a bunch of essay questions. That's crazy. But it'll be half like short quiz style questions. I like true or false questions, fill in the blank style questions. What I like about true false questions is making them more interesting, more like a short answer question. So if the answer is false, you have to make the statement true to get the points for saying. You can't have to say false. You have to give me then a true statement about that particular topic, like change it so it's true. I think that's much more interesting. And then 3 short coding questions. Again, it's timed. I plan it so that like each of those coding questions should take about 10 minutes. They're not super long or anything. And then if it were to take you double that, that'd be 20 minutes. Right, so that's an hour worth of the exam for 3 of those questions, right? And then like 15 quiz style true false questions, I figured like a minute each. For that. So you could do it in an hour 15. I don't usually time them because that seems silly too. I've never had someone give me, I mean, you have deadlines, but no one's like, get this done in the next 30 minutes. Like, that's just silly. So, yeah.
You have to, like, once you open it, you have to finish it?
No, you can save it and come back to it. Yeah, I don't like putting time limits on things. Yeah.
Is it like another thing through like creating a repository, or is it on campus?
No, I just have you paste the code in, and I feel bad about it, but trying to get people to do that under, yeah, I just say paste it in. Like, do it in PyCharm and then copy paste. Works out pretty well. And I'll give you, before the 28th, I'll send you, or I'll post last year's midterm for you to take a look at. And then on the 21st, so my hope is I'll be here on the 21st. I'll let you know, because on the 20th, I'm going to the Free Press International Marathon, and I haven't run very much lately. I ran a lot in the spring. The summer, I started having heart issues, and like it took me 2 months to see a cardiologist for him to be like, "Oh yeah, you're fine. Don't worry about your heart palpitations. They're nothing." Okay, sure. So I'm a little bit out of shape, and even if you're in shape, if running a marathon sucks, but it's still fun. So I'll probably be here on the 21st. If I'm not up for it, because I just can't walk at all because my legs are so dead, I'll shoot you a message really early-ish in the morning. So like by 10 or something, I'll know if I'm up for the day or not on the 21st. Is 10 a.m. enough notice if I need to not make it? Okay, I'll let you know. I'm planning to be here. Usually I'm just really slow, and I just hobble around campus, and it's lots of fun. But should be a good time. The weather's gonna be great this weekend. Really nice. So good weather forecast. All right, questions, thoughts, concerns? Doing okay? All right, we got a plan through the midterm, and then again we'll pick up the advanced topics, pick up our final project, have a week off for Thanksgiving break, a little bit of time, final project work time, which is awesome. Well, thanks everybody. Then we can get working on the project or your Xylabs.